So in this video, the first of two, I'll be looking at how to do some basic analysis of cross-section type data involving some categorical variables and some numeric variables. Sort of data that you might get if you do a questionnaire or a survey of some kind. So this is fairly typical data that needs analysis. Now, the first thing to do, of course, is to import our required packages, NumPy, Pandas, and matplotlib .pyplot in the usual way. So I'll run this cell. Now, I'm also importing here matplotlib itself rather than this subsection of it as MPL, because I want to use this style.use function, which enables you to style your charts in a certain predetermined preset style. Now there are a number that you can choose from. The one I'm using is ggplot, because I want them to look like charts produced by the ggplot2 package. It's the well-known R package, because I like that style. If you've seen those, if you've used it, you'll know what I mean. So let me import that. So from now on, any charts I create will adopt this ggplot style. So, as always, we first of all need to read in the data that we're going to analyze. So I'm reading this in the usual way from a CSV file that's in my working directory. So I don't need any path to it. It's the read_CSV function from Pandas. This time, however, I'm including a couple of options, engine and dtype_backends, which are both set to PyArrow. Now, what this does is it uses the PyArrow package, so you need to make sure that that's installed. You can do that, of course, via PyCharm. And what it does is it economizes on the memory usage of your data set. I think it's becoming quite a popular way of doing it. In fact, I think it might even be a requirement in the most up-to-date versions or upcoming versions of Pandas. Now, in case of my very small little data set here, it makes very little difference. But obviously, if you're reading in a very big data set with lots of cases, hundreds, maybe even thousands, lots of variables, then being able to economize on memory and it also will speed things up is obviously going to be useful. So I'm going to do that here. So that's reading in my data set. Let's have a look at it. It's very small. There's only 20 cases, 3 variables, so we can easily display it all on screen. Remember, if it's much bigger, you can use those head and tail functions to just show the beginning few rows and the final few rows. So here it is. It's the one I've used before with these 3 variables, gender and site, which are category variables, and excuse me, usage hours per week, which is a numeric variable. Here's the index. Only 20 cases this time. It's sufficient to illustrate the techniques here. If you actually want to know what data types these variables are being imported as, you can use the dtypes property here on the data frame. As you can see, gender and site have been imported as strings, which effectively means that they're categorical variables. In fact, you can convert these to the category. There is an actual category data type, I believe, in Pandas, which you could convert these if you wanted to. Again, I think the only advantage of that is that it uses less memory than a string, but otherwise I don't think it makes much difference. I'm not going to do that here. Now, usage has been imported as an integer variable, 64-bit, because all the values are integers, although I'm assuming here that this is more of a continuous sort of float variable, which rather than integer. You could convert it into a float if you want, but again, that's not necessary. So what I'm going to do first of all is show how to create a simple frequency distribution of one of the categorical variables, in this case site. You can do this for any categorical variable, of course. Now, I did look at this briefly in the previous video. What you need to do is use this value_counts function. So first of all, select the variable in the usual way here with this syntax, then a dot, because you're going to be using a function, value underscore count, and this is a function, hence the brackets, and I'm also going to be using this option, normalize, setting equals to true. What that does, I think I touched on this last time, is it, rather than returning the number of values in each category, which value counts on its own would, it returns them as proportions of the total. And since I then want those to be percentages rather than just proportions, I multiply by 100. So that is the code I need to return the proportion of each value in sight. So the three values are Twitter, Facebook, and Pinterest, as percentages of the total number of values in that variable, which of course is 20. Now I'm storing this in a variable, site underscore FREQ, so that I can then refer to that later without having to type this whole thing out again. So having stored it in there, I then display it in my notebook, and there we have it. You can see the percentages here, 40, 35, 25, which should of course add up to 100 if there's none missing, and those. So that's often what you want to do, rather than just simply counting how many values there were, how many Twitters, how many Facebooks in your data set. Show it as percentages. Now, typically you of course would graph such a frequency distribution with a bar chart. Now, I think I've illustrated this before. It's very easy. Just take the variable containing this data, and then just use the plot.bar function. In pandas in matplotlib, this is the standard way of creating a chart. You put plot, a dot, and then the type of chart that you want. If you don't put something like bar, then it will plot a line graph by default, but you can always specify what you want. There are options you could set, but I'm not showing them here. Now this on its own will produce a fairly decent chart. However, it wouldn't be quite as formatted as you'd like, because what you'd find, for example, is that the labels here on the horizontal axis, which would of course be Twitter, Facebook, and Pinterest, would be vertically aligned rather than horizontal, which makes them hard to read. So I'm using this option here, xticks, to rotate them horizontally, and what you do for that is rotation equals 0. So once you've put the code in to create the chart that you want, what you would normally then want to do is to use various functions available in matplotlib pyplot, which remember we access with this alias plt, such as xtick, such as title, such as ylabel, such as xlabel. Most of them are fairly self-explanatory. It's clear, obvious that this one is going to put a title to your graph. This one's going to put a label on the y-axis. Obviously, there's an option xlabel, which puts a label on your x-axis if required. This one here shows the graph itself. This one affects the tick marks on your horizontal axis, xticks. So you've got options to rotate the labels so that they're horizontal, and you can also align the labels within the center of each bar as well, which is what I've done here. Now let's see what we get. Now, by the way, you don't need necessarily to use this plt.show function here. However, if you don't do that, you'll find that there's a rather strange looking piece of text plotted above your chart, which you don't really want. So always use this pl2show function at the end. So if I run that, we see we get a nice looking chart. It's in the ggplot style. You'll recognize this if you've seen those. Here's my title, here's my y-axis label. I didn't need an x to put an x-axis label in, because it will use site here. This will be the x-axis label, and the labels on each bar are fine. But notice, if I hadn't used rotation equals 0 here, they would be vertical. They would be reading vertically, like this one, in other words, which is of course not what you want. You want them horizontal. And also I wanted to center them as well. So Basically, to create a chart, you use an appropriate plot function for the chart you want, and then by using various functions available in matplotlib, using plt dot to access them, that you can format to make it look better. Okay, so that's how to take a category variable and do a frequency distribution, either just a count if you want, or if you want proportions or percentages, use this here, normalize equals true as an option, and then times 100, and then of course plot them with a nice bar chart. And using this ggplot style, I think they look rather nice. Now, for any numeric variable, of course, you don't want a bar chart, you want a histogram. Well, again, that's very straightforward. There is a function called hist, which will do that. So here I'm going to do that here. So I'm going to take the usage in hours per week variable, which of course is a numeric variable, and plot it as a histogram. I did plot the distribution of the histogram. Again, on its own, that will give you a fairly basic histogram. But if you want to make it look a little better, you can format it again with these options. Title, that's fairly obvious. X label, that's obvious. Now here on the X ticks one, what you can also put in, and if it's the first one that you put, first parameter here, or parameter value, you don't necessarily need to put the label for that parameter. It would in fact be ticks, as I've done here. But so I could have put ticks equals, but then that's the first one, so it takes that as being the ticks option. So you put in a list. Remember, a list is in brackets, square brackets, of the ticks that you want on the axis. So I know in my data, you'd need to check what the minimum and maximum values of your data set is, so you can determine these. So I've determined that those labels there will just do fine. I have also added a X label here because otherwise it doesn't put one that's appropriate otherwise by default. So again, let's show this one. And there we get a nice histogram. By the way, by default, it will put them into 10 bins, into 10 intervals. So if you count these, you'll see they're 10. You can change that by using the bins option in here. Again, remember, if you want to see what options are available, just place the cursor on the function, press Shift-Tab, bring up the little help screen. You can see the options that are available. And as you can see, one is bins, which takes an integer, which you can set the number of bins. As you see, it's 10 by default, but you can change it to more or less if you prefer. Now, this actually is a fairly odd-looking histogram because this is only hypothetical data. With realistic data and a big data set, you'd probably hopefully be looking for a more sort of normally type distribution. But here you can see how we can get a nice histogram. Okay, so the next thing that you would want to do, having produced a frequency distribution of each category variable and histograms of any numeric variables, you then want to start doing some what are called cross-tabulations, or also called contingency tables, or indeed in Excel they're called pivot tables. In other words, you want to take a particular variable, the responses to a particular variable, to a particular question, for example, if there's a questionnaire, and break down those responses by some other variable. So, for example, you might want to break down the site, the chosen site by these respondents, the site they use the most, according to their gender. And to get what, say, is, I would typically, I think the most common name for that is a cross-tabulation. But I'd say it's called a pivot table in Excel. Now we can do that with the group by function. This, I believe, is the same name of the function in our tidyverse set of functions, which will do this, if you've ever used that before. So I'm going to group these responses. So what I'm going to do is I'm going to group site by gender. So as you can see, what you do is you put the data frame, obviously, dot, then the group by function, then in brackets, because it's a function, you put a list here. Notice the list, they're in square brackets, where the second variable is the one that you are breaking down, and the first one is what the variable you're categorizing it by. So in other words, I'm wanting to break down site by gender, and then I want the actual it to look at the site values and give me a count of them. So this so notice, having put the grouping here in the function, you then put a list showing the variable you're wanting to, again, it would be this variable here that you're wanting to break down, a dot, and then the value counts function to produce a count of the number of values in each cell. So in other words, this should give me a breakdown showing how many, for example, how many men chose Facebook, how many chose Pinterest, how many showed Twitter as their main social media site, and the same for females. So let's have a look at what we get. And there we go. That is what I'm getting. So as you can see, site has been broken down, has been categorized by gender. So now this should add up to 20, because there were 20 cases, and of course it does. So in other words, this is telling me that of the females in my data set, 3 of them chose Facebook as their main social media site, 3 chose Pinterest, 3 chose Twitter. For males, it was 4 Facebook, 2 Pinterest, 5 Twitter. Now those are the actual counts. What if I wanted these as percentages, rather like I did with a frequency distribution? Well, you might think, why not use what I did before, put normalize equals true in here, and then just times by 100. Well, I tried that and it didn't work. I'm not sure why. I don't think I was doing it wrong, but it didn't work. So I had to resort to a different method here. So what I've got here is the same as I've got up above, up to this point here, same as here. But then I'm using the transform function to modify these values, to transform them. And what I want is to turn these into percentages of the total. So the total, of course, is 20. So I want this one, 3, as a percentage of 20, which of course would be 15%. Now to do that, I'm going to use the transform function here. And what you supply to that function, what you pass to it, as the jargon is called, is what's called an autonomous lambda function. Now, all this means is that you put the word lambda and then some variable. X will do fine. It can be anything you like. X will do, or Y or Z or whatever. X is often used, of course. And then a colon, and then you put the function, then you put the expression telling what you actually want to happen. So what this does is it uses this function on each of the items in your data set. So we've got these 6 values here in my grouping. X stands for each one. So what this does, it takes each value, so it starts off with this first one, 3, divides that by the sum of those values. So notice I've used x.sum and brackets. So I've used the sum function here to sum these values to give me 20. So the first one would be 3 over 20, and then times by 100 will give me 15%. Then it will work on the next one, which again is 3 of the same one, 3 over 20 times 100, 15, then the next one, and so on. So it works through, it's like a loop. If you know about programming, it's like a loop working through each value, but it does it automatically. I believe it is called a vectorization, if that's the word that's used. But as I think you can see what it's doing. So I think you'll be able to supply your own functions here in a similar way. So I'm now going to store the results of this in a separate variable so that I can refer to it easily later on without having to type this whole long piece of code. So I've stored it in there, and then I'm going to display it, and with any luck, it does exactly what I want. As you can see, that one is 15%, 15, 15, that will be 20, that will be 10, that will be 25, yeah. So here we've got these things turned into percentages now, rather than just actual count. Obviously, these add up to 100%. So as you can see, it would have been easier if I could have just put normalize equals true and then times 100 like I did before, but as I say, I tried that, it didn't work. So I've had to use this transform function, but that is useful because you can use this transform function to convert or transform the values here in any way you like, not just creating percentages I've done here. And hopefully you can see exactly how I did that. Now, of course, I can display this in a chart. It will be a bar chart with a number of bars, of course, one bar for each of these values. And it will be, what I'm looking for is a chart where these first three are grouped together under female, and the next three are grouped together, stacked together is perhaps the best word, under male. Now to do that, so I take the variable which contains this data, and I'm going to plot it as a bar chart. But notice here I've put this option unstack. That causes the three bars to be stacked, plotted alongside each other rather than stacked on top of each other, because I don't want that. I want them unstacked. I want them next to each other. Then, of course, I've used some options here again, just to formatting. We've seen this one and this one and this one. The other one here we haven't seen is where I'm using the xticks function again to create the ticks and the labels I want on the horizontal axis, because by default it's going to use F and M, which is not descriptive enough. So I've set labels as female and male, and because I'm using my own labels, I then have to tell it that I want two ticks on my and hence two labels on my horizontal axis, because for female and male. Make sure you get these in the right order, and you simply indicate as a list here supplied to the ticks option the number of ticks you want, starting with 0 and then 1. So obviously if I needed 3 ticks, I'd put 0, 1, 2, and so on. Just need 2 here. The title and Y label are obvious, and then I show the chart. So let me show that, and here we get exactly what I wanted. Again, in the ggplot2 style, unstacked, so that these are plotted alongside each other. These are all, of course, with all 15%. This one was 20, and then 10, and 25. And of course, they're grouped according to gender, which is what the grouping that I did. So in other words, I broke down, remember, responses to site by gender, and I showed the proportions. Notice it also put a nice legend here by using the values here. And in this case, this is perfectly fine, that the title of the legend is correct and the options are correct. If not, then as we'll see, you can use a PLT, the legend function in matplotlib, so it's plt.legend, to create a more appropriate legend and to put it in an appropriate place on the chart if it doesn't do it properly by default. But here the default is perfectly fine, so I've left it at that. Okay, so that completes this first video on analyzing category data.